Today we are going to be doing lesson 36, distributive property, and then minus signs with negative exponents. So since variables stand for specified real numbers, all the rules for real numbers also apply to variables. Thus, fractions that contain variables are multiplied by using the same rule. So if I had mx over 4y times ax over 2y, I am just going to multiply like I normally would, but I just have it in fraction form. So mx times ax would be amx squared over 4y times 2y would be 8y squared. So as I'm doing the distributive property, it's the same concept. So I'm going to multiply this times this, and I'm going to multiply this times this. So in example number 1, x squared times x squared would give us x to the 4th over y squared times y would be y cubed. And then we have minus x squared times 3y cubed would be 3x squared y cubed over, I have y squared times m, which would be y squared m. Now I can't leave it like this. My first fraction, x to the 4th over y to the 3rd, that one is in its simplest form, so that stays as true. So x to the 4th over y cubed minus, this is where I need to reduce. I have a y cubed over y squared. So my 3 would stay the same, my x squared would stay the same. But if I have y cubed over y squared, it would just be y in the numerator and nothing in the denominator when I reduce that down. And then it would be over m. So 3x squared y over m. So this is my answer. Okay, let's do another one. I have m over z times axp over mk minus 2m to the 4th, p to the 4th, and I put that over 1 just so that I remember that that is in my numerator, not in the denominator. So let's start multiplying this out. M times axp would be maxp over z times mk is zmk minus 2 times m to the 4th, p to the 4th. So I would have 2 times m to the 5th, p to the 4th over, and I have z times 1, which is just z. Now this first fraction I can reduce down because I have m over m, which would just be 1. So I have what is left, axp over zk minus, this doesn't have anything that I need to reduce out, so 2m to the 5th, p to the 4th over z. And that would be how I would write that answer. Okay, one more example. Example number 3, I have ab over c squared times xab over c plus 2bx. I'm going to put that over 1 so that I do remember that that is in the numerator, minus 4 over c squared. So I'm just going to multiply, multiply, multiply because I'm using my distributive properties. AB times XAB would be A squared B squared X over C squared times C is C cubed. Plus, I have 2 AB times BX, so I have AB squared X over C squared times 1 is C squared. Minus 4 times AB, it would be 4AB. C squared times C squared would be C to the 4th. I don't have anything that needs to reduce down, so this is how I would write that answer. So we need to remember that when we are solving an expression with an exponent, a minus sign in front of an expression indicates the opposite of the expression, but the negative exponent has a different meaning entirely. So if I have 4 squared, this would just be 4 times 4, which is 16. If I have 4 to the negative 2nd power, remember that I need to then flip this to the denominator to be a positive exponent, then I can solve it. So it would be 1 over 4 squared, or 1 over 16. Now this is where it gets a little bit tricky. This negative sign is not actually part of what we are squaring, and it just means the opposite of 4 squared. So 4 squared is 16, and the opposite of that would be negative 16. Now this is actually a negative 4 that is being squared because it has those parentheses. So negative 4 times negative 4 is 16. If I have negative 4 to the negative 2 power, it would actually be 1 over negative 4 squared, which would actually be negative 1 over 16. And then if I have negative 4 to the negative 2 power with the negative 4 in those parentheses, I would have 1 over negative 4 to the 1 over negative 4 squared, which would be 1 over 16, because negative 4 times negative 4 is 16.